Imagine that Earth suddenly becomes the closest planet to the Sun. In a single instant, it disappears from its familiar orbit and reappears where Mercury once revolved just 58 million kilometers from the Sun. By everyday standards, that may sound like a vast distance. By cosmic standards, it is almost right next door. And in our former place, within the habitable zone, a small, scorched planet remains. So what would happen to Earth? How quickly would life perish? And would humanity have even the slightest chance to survive? First, we need to introduce a crucial assumption. We assume that Earth is moved instantly, that it does not break apart, that its atmosphere, oceans, and moon remain intact, and that the planet continues to rotate on its axis. Without these assumptions, the scenario would end in a single second. But even under such idealized conditions, the consequences would be catastrophic. In its original orbit, Earth received about 170 per quadrillion watts of solar energy. At Mercury's orbit, that amount increases by roughly 6.5 times. This doesn't just mean it gets warmer. It means a fundamental and irreversible transformation of the planet's climate. Within the first days, temperatures would begin rising everywhere. Glaciers and polar ice caps would melt rapidly. Climate zones, which life adapted to over millions of years, would disappear. Within weeks, the average global temperature would approach the boiling point of water. The tropics would become completely uninhabitable, and mass extinction. But this would only be the beginning. One of the most dangerous processes in planetary science would take over: the runaway greenhouse effect. The oceans would begin to evaporate. Water vapor, a powerful greenhouse gas, would trap even more heat. Temperatures would rise faster. Evaporation would accelerate, and the cycle would feed itself. There would be no escape. This is exactly how Venus once transformed into a hellish world with surface temperatures around 860 degrees Fahrenheit. Earth would follow the same path but far more quickly, because it already possesses vast oceans capable of accelerating the process. At this distance, the Sun is dangerous not only because of heat. Ultraviolet radiation and the solar wind would begin to tear the atmosphere apart. Water molecules in the upper atmosphere would break down. Hydrogen, the lightest element, would escape into space. Oxygen would remain and begin reacting aggressively with nearly everything on the surface. Iron will turn into oxides, silicon into silicon dioxide, magnesium, aluminum, and calcium into their oxides, and sulfides into sulfates. The Earth's surface will begin to rust and burn at the same time, but without flames. Day and night would no longer be equal. Due to the Sun's immense tidal forces, Earth would begin to lose its rotation. Days would grow longer, and within hundreds of thousands of years, tidal locking could occur. One side of the planet will forever face the Sun, while the other will be plunged into eternal darkness. A sun-baked hemisphere will form, along with a dark, hellish side, separated from the sunlit side. Temperatures on the sunlit side would reach between 750 and 950 degrees Fahrenheit. The atmosphere would become metallic. At such extreme temperatures, sodium, potassium, and magnesium would begin to evaporate directly from rock. A metallic haze would fill the sky, its spectrum resembling that of hot exoplanets observed around distant stars. Mineral rain would begin to fall, droplets of silicates and aerosols of metal oxides returning to the surface. Scientists suspect similar processes on Venus, but for Earth in this scenario, they would be almost unavoidable. Could humanity survive on the surface? Absolutely not. The only theoretical chance would be deep underground shelters with fully sealed ecosystems and protection from radiation and extreme heat. But even there, as the planet continued to warm, survival would be temporary. Cracks will begin to form, hot fluids will flow in, and there will be releases of carbon dioxide and sulfur. The lifespan of such shelters ranges from a few years to a couple of decades, provided supplies last. At that point, it would no longer be a question of human survival. It would be a question of how long we could delay the inevitable. All that would remain of the blue planet would be memory if there were anyone left to remember it. Swapping orbits with Mercury would be a death sentence for Earth. Not an instant one, but an unavoidable one.